Section 3.6, the negation of conditional statements and Morgan's law. Two objectives. The first one is to write the negation of a conditional statement, P then Q, and use the Morgan's law. The Morgan's law in chapter 2, if you recall, is the complement of the intersection of set A and set B is the union of the complement of the A and the complement of the B. And the other one is the complement of the union of set A and set B is the same as the intersection of the complement of the A and the complement of the B. You can treat it by distributing complement to each term inside of the parentheses. Complement of the A, which is the A prime, complement of the intersection is the union, complement of the union is the intersection. Okay, the De Morgan's law for the compound statements. For the negation of the connective or the negation of P or Q is equivalent to not P and not Q. You treat it by applying the negation to each term and make a note, negation of the or is the same as and. Similar way, negation of P and Q is negation P or negation Q. Or we can say negation of the and is the same as the or. From the previous section, we know that the P then Q or the conditional statement is equivalent to the statement not P or Q. The not P, negation of P or Q. Now, when you apply the negation to the if then or the conditional statement is the same as when you apply the negation to not P or Q. Use De Morgan's law. Negation of negation P, that becomes the P. Negation of the or becomes N. Negation of the Q is not Q. Therefore, we have the negation of the conditional statement P then Q equivalent to the statements P and not Q. On the table is a summary. For the conditional statement P then Q, the converse Q then P, the inverse not P then not Q, the contrapositive not Q then not P. We know that the P then Q is equivalent to the contrapositive. The converse, not the converse, sorry, the conditional statement equivalent to not P or Q. The negation of if then is equivalent to P and not Q. When you have the conditional statement, you swap them. It doesn't mean that they are equivalent. Like for the third row here, it means the conditional statement not equivalent to the converse. But the converse and the inverse, they are equivalent. And also the last case, the P then Q or the conditional statement not equivalent to not P then not Q. So basically when you have the position say the same, you apply the negation is not equivalent to the original statement. Next, we are going to prove the laws on the table. What we are going to show is the statement not P or Q or the negation of P or Q is equivalent to not P and not Q by using the truth table. Or from the table, you can see the highlighted two columns that what we're going to show that the result going to be the same case by case to show the equivalence of the compound statement. What we have, we're going to construct a table for the P, construct the column for the P or Q. and then form the negation as the compound statement on the left side of the equivalent symbol. And for the right side of the equivalent symbol, we're gonna need not P, not Q, and the column to combine them with the connective and. So for the left compound statement, the statement P or Q, we call the or. Only the case is false or false, it will return the false result. Statement P and Q, by default, we have the four combinations: true, 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 false, false, true, and false, false. For true or true, gonna return the result true. True or false, gonna be true. False or true, gonna be true. False or false, this is the case, gonna give you false. And then whatever we get here, we're gonna apply negation, which is the opposite of the truth value. Then we're gonna get false, 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 and true. Set it aside because this is the value for the left statement. Next, we're gonna construct more columns for the right compound statement. For the not P is negation of the P. The opposite truth value to the P gonna be false, false, true, true. Opposite to the statement Q gonna be false, true, false, true. And next we're gonna connect these two with the and put the result on the rightmost column. Put the note on the side here, the and. Only both of them are true. The result gonna be true. Otherwise, you're gonna get the false result. So false and the false return the false statement. False and true gonna be false. True and false gonna be false. True and true gonna be true. Now we look at the truth value of the statement on the left and statement on the right case by case. Looks like they are exactly the same, one by one, case by case. Therefore, we are done proving. And this is our general statement that the negation of P or Q is equivalent to the statement not P and not Q.